Matt Baker is going to enlist your sympathy about his VPN experiences over the past while.
Hi, I'm going to switch gears a little bit and talk more about a different type of service provider, one that my company falls into. That's hosting service providers and the sort of application of VPNs in that space. The title of the presentation is Very Pleasant or Painful Networking, and it sort of is meant to highlight some of the highs and lows of building and maintaining IPsec-based customer access VPNs. So let me hop into it. So VPN behind the scenes. IPsec-based VPNs can be highly effective and can prove very valuable for a myriad of applications. Just to give you an example of what Intel Online Services does with them. We're using them to provide quick, affordable, sort of next-day connectivity to hosted services, as well as providing provisioned VPNs for application service providers. However, one thing we found is building and maintaining virtual private networks can be very troublesome and frustrating at sometimes, particularly because we're dealing many times not only with customers as in the big customer, but end users as well. So this presentation is meant to highlight some of those issues. So a quick agenda. I'm going to quickly talk about what I'm calling the distilled taxonomy of VPNs, or IPsec VPNs. This simply means the ones applicable to today's presentation. Some of the technology challenges, those things that are sort of inherent in the technology itself. Some of the environmental challenges, those things when you introduce IPsec into a highly dynamic environment like the internet. Again, some more environmental challenges, human factors, and some conclusions. So quickly, the first one I will talk about will be these are some buzzwords: site-to-site, LAN-to-LAN, or branch office connections. They're typically VPNs connecting two networks or groups of networks. They employ mostly main mode IKE with pre-shared keys or certificates. They're CPE-based devices, device-to-device connections, typically at the edge or somewhat inside the edge of your customer's network. Routing and addressing in these virtual private networks is a major issue, as well as the security of those tunnels relying on your customer's security. So here's a quick simplified view of what I'm talking about when I say a LAN-to-LAN VPN. The second is client-to-LAN VPN, or remote access style VPNs. These are tunnels that typically connect a single node to a remote network. They typically employ aggressive mode IKE with pre-shared keys, certificates, tokens, all sorts of AAA methodologies. They're typically client software driven. Security appears more tightly controlled, and I'll go into why. Access policies as well can be centrally controlled, and that can be very important when you're dealing with a disparate group of users. So again, another simplified view of what I'm talking about when I say client-to-LAN VPNs, an end user to a remote network. So technology challenges, and again, what I mean by these are things that are inherent or sort of come with the territory with IPsec. And they're typically some fairly mundane and would seem to be easy to address, but obviously aren't. The first one is bad NAT. When you're dealing with many end users, you typically run into challenges with NAT. Obviously, IPsec has inherent issues with NAT, particularly when you're doing many-to-one NAT, or it goes by many names, port or IP overload NAT, etc. And also knowing how any NAT implementation will affect IPsec is difficult to do. And this means that if you have an end user who's trying to create a tunnel to your network, or to, I should say, their network that you're hosting, it's difficult to tell from what they're telling you what might be wrong. So it's important to assume the worst with NAT and tell your customers that up front. Some NAT implementations won't even allow a tunnel to be created, while others will allow single tunnels to be created and then the subsequent tunnels that are created tear down the initial ones. The use of NAT is pervasive in broadband and low-cost access markets. So large LECs providing, say, DSL utilize CPE-based NAT to ease implementation complexity and also to conserve IP space, obviously. Many end users, therefore, are unaware of the nature of their connectivity to the internet. And I say this as your customers' end users, the folks who are the consumers of the tunnels. And industry solutions, one that was bandied about was RSIP. These are very slow on the uptake, and this issue continues to be a major problem in most implementations. So a lot of vendors are shortcutting around it. So some strategies that we have sort of used to address this issue is the major one's education. Sort of being prepared with customer documentation to describe how you can work around that. One of the obvious ways to do it is to use one-to-one translations. Most IPsec implementations can cope with that. Be prepared to assist your customers when talking with their service providers. If many of your customers are going to be behind a NAT gateway, say you're working with a smaller customer who has a low-cost access methodology, if there's going to be many customers behind that, sort of a LAN-to-LAN style of access might be applicable. And also consider maybe a different VPN implementation as well as vendors supporting UDP wrap clients. That's one of the major things going on with with vendors to address the NAT issue. Troubleshooting complexity is another thing that comes with the territory. First of all, the tool sets that are provided with many products are fairly immature. The varying standard implementations of the protocols make root cause fingerprinting difficult. And what I mean by this is if your customer is having a problem or one of their end users is having a problem creating a tunnel to their network, depending on what device you're using, it's not obvious what's going on, and that's difficult. The very nature of virtual private networking makes troubleshooting very complex. Obviously, they're trying to carry some sort of important traffic between their network and the hosted network at your side. So when there is trouble, sniffing packets is useless in between because obviously they're homogeneous and encrypted. Again, another thing that we've brought to bear to address these issues is building some sort of IPsec debug target. You can think of a Linux box running FreeSWAN, for instance. Some type of device that allows you to see what's going on and obviously not having to turn debug on the devices that are very busy providing other tunnels for other customers. Reduce the complexity of your implementation by trying to enforce product standards and ensuring the number of device and vendor combinations is minimal. And structure access networks with the devices that accommodate simple packet inspection. So this means where traffic is popping out of these tunnels, some sort of device that allows you to inspect what's going on. That's one quick way to address that. The many levels of interoperability are also an issue. You'll typically, as a service provider, selling this type of service, you'll have users who already have some sort of VPN implementation that they use for remote access at their site, etc. So they'll maybe want to use that, and that can be troublesome, especially if you're running, vendor A, vendor B. So the varied implementations make cross-vendor interoperability troublesome at best. Many of the critical features that you might be using are often vendor-specific, such as failover, etc. Products are often streamlined for usability, and thus the extensions that vendors have put in place are difficult to turn off or impossible. Client-to-LAN interoper is particularly problematic. VPN clients have become commodities, thus vendors don't necessarily have a goal of interoperability. So vendor A's client isn't necessarily going to interoperate with vendor B's, and it's not in their best interest maybe to make that work. And also potential cost savings with trying to leverage a customer's existing solution. Those cost savings are often consumed by the minutia of trying to get things to work. Intra-vendor interoperability, this is typically a no-brainer from a technical standpoint. However, operationally it can be very difficult because of the disparate command interfaces, orders of operation and creating tunnels, stuff like that. Also, client-to-LAN or OS application interop is also an issue. Will a particular client run on a certain operating system? As you'll see, many times Unix flavors are conspicuously absent, Mac, etc. Multiple VPN clients installed on somebody's machine, if you're doing client-to-LAN at the same time, can also be problematic. So you need to expect that you're going to see many of these application and client interoperability issues. So some strategies: enforce standard device and client combinations. Strongly set expectations in terms of what you're supporting as standards. Proactively publish known compatibility issues, and obviously test. Environmental challenges. These are the challenges that we've run into, or you can run into when introducing IPsec into a sort of dynamic environment like the Internet. Quality, reliability, and performance is a major one. Customers are many times unaware of the costs associated with using the Internet for mission-critical data transport over an IPsec VPN. Application issues can arise easily as you introduce more latency and bandwidth variance. Varying performance issues introduced by the vagaries of the Internet are difficult to explain to customers many times. And the cost of doing investigations to determine why customer B's tunnel is going slow are very high. Customer ISP selection is a major factor. If you're not controlling the path between them and you, obviously the quality of their Internet connectivity is going to play a major part in the type of service level you can offer them. So it's important to set expectations solidly. And finally, needing to be aware that custom applications and DB activity over these tunnels, when performance is an issue, can cause a lot of grief for your customers and thus for you. Some external stumbling blocks. Many IT organizations are unfamiliar with IPsec, and this sort of makes opening holes to allow for client-to-LAN or LAN-to-LAN access out of their network difficult. Customers hesitate to open these holes. Like I said, UDP is typically seen as evil incarnate to most firewall admins, and thus one of the major parts of IPsec openings are problematic. ESP and AH are again little understood by most folks at the enterprise level, and therefore it makes them suspect. Some ISPs have also been known to arbitrarily block tunneling protocols for any number of reasons, and this can be difficult to isolate and also difficult to address once you find what the issue is. So some strategies. Drafting SLAs can be real difficult, and introducing this type of environment is no exception. The likelihood of performance fluctuations means that you need to craft an SLA that protects both you and your customer, and typically this means setting concrete expectations as to what kind of performance you can expect over this type of tunnel. Educate your customers with regard to the implication of Internet-based networking, sort of compare and contrast with other traditional ways of connecting a customer to a hosted network. Gather metrics on device utilization, available bandwidth, sort of the normal stuff, so that you can speak from a data-driven spot, so that you can help your customers understand what's going on as it pertains to your equipment. And also gather Internet performance metrics and leverage Internet communities that might tell you what may have happened, what is happening, etc. So there's also a number of security concerns that come along with VPN. It's a technology to provide security, IPsec VPNs, but there's also some issues around it. Client-to-LAN VPN is considered by many to be more secure. The scopes of tunnels are more well-defined. Security policies can typically be centrally controlled and pushed out to the clients. And there's also a stronger level of user access control that provides. However, traffic bifurcation, or that allowing traffic to go outside the tunnel and down the tunnel simultaneously, can be problematic because it allows for sort of the route through Trojan attacks to take place. LAN-to-LAN tunnels, things get a little bit more muddied with LAN-to-LAN tunnels. The scope of the tunnels is typically more amorphous. Security policies and protective measures cannot be centrally controlled. Rogue access is simple once the remote network, or your network for that matter, is compromised. And a level of user access control is lost with LAN-to-LAN tunnels. So some strategies to address these security concerns. One is to just simply enforce a policy of no bifurcation or no traffic forking. The risks are quite great otherwise. Favor client-to-LAN as a technology in terms of the first option, because obviously it's more well-defined and can be controlled a little bit more. Scope LAN-to-LAN tunnels carefully. Educate customers regarding security issues with LAN-to-LAN tunnels, publish white papers, etc., so they're aware of the issues. And also expect lapses of security on the remote end. You need to be vigilant about protecting your own network, obviously. Routing and addressing challenges. I'm sure many of you are aware of the way most client-to-LAN implementations work. So routing and addressing issues are typically moot with client-to-LAN. However, with LAN-to-LAN, issues abound, and I'll show you why. Say you're running a hosting network and you're hosting a number of customers' networks or websites, etc., and they want to access that stuff in order to put content up, manage the systems, etc. Many times you'll have customers who are utilizing the same private space or same, whatever, and you'll therefore have customers coming in over LAN-to-LAN, sourcing from addresses in common. So obviously at your edge where you're terminating these tunnels, routing can become problematic. It can become problematic throughout your network. So again, use of private addressing is pervasive, and this makes collisions inside your network inevitable. Advanced routing techniques like policy-based routing, source routing, are commonly not feasible or available, and route sharing is typically undesirable. This is sort of a side issue. It can be complicated and therefore difficult to control what is going on within your own network. If route sharing is not used, obviously you're going to have to figure out some way for your customers to plumb the traffic within their network to the endpoint and over to your side. So this can be problematic because many of the customers that you're dealing with may find it difficult to understand, okay, I've got this new device sitting on my network. How do I get the traffic there? Another issue with that is if they, for instance, start redistributing routes throughout their network for resources on your side, if there's leaking, etc., this can be pretty disastrous for your environment. So good NAT. There's a duality to NAT with IPsec and to creating tunnels and providing this type of service. NAT can be very beneficial because it can help you cope with these issues. It can create a layer of abstraction or a buffer between you and your customers. It can simplify your own internal routing, and it can mitigate customer internal IP address conflicts. And it also returns a major level of control to you as the service provider. The downsides are obviously complexity. You're doing all these translations to all these networks. It can get pretty spaghetti-like. Bidirectional traffic initiation with, like I was saying, many-to-one NAT can be problematic. And there's also application incompatibility issues with NATing. So here's an example of how you might deal with that simplified. This is obviously very simplified, but this might be how you deal with those collisions, NATing a customer over to an address range that you control, and therefore the routing within your network is highly simplified. So some strategies. Again, you need to provide a lot of documentation. A lot of what I'm talking about, as you can see, is education. Consider an architecture that protects your critical services from leaking routes on a customer end. Build an abstraction layer into your network where traffic and addressing can be normalized as it enters. Utilize NAT to retain control of addressing. Have a policy in place regarding the use of private addressing and what you're going to expect your customers to do in the event that you run into some collision problems. Take a building block approach. Layering typically increases the flexibility of the services you can provide. It also compartmentalizes many of the aspects of providing an IPsec VPN. You can at one spot provide connectivity, the basic tunnel creation, teardown, access control at another, natting, etc. It also promotes defense in depth, which is obviously important. And also be vigilant when selecting a VPN product, one that allows you as a service provider to do many different things with many different customers. Many of them are typically designed for the enterprise, so that's important. Human factors. Perception and expectations. This is probably one of the largest things that we run into. The underlying connectivity architecture, once IPsec VPN is in place, is abstracted. And the traditional troubleshooting techniques that a customer might use to understand what's going on, why things are going slow, etc., can lead them astray because obviously the underlying network between them is obscured. So this means education is really important. Letting these smaller customers who maybe don't have a broad understanding of what's going on, letting them know that when a tunnel is built, the traffic obviously or the hops along the way, that type of stuff is abstracted from them, and therefore you need to help them understand how to address the issues, where to look to find the issues. I'm saying issues a lot. Issue ownership conflicts are also very common when you're doing this type of service provider provisioned type of VPN. Therefore, your customer relationship needs to be well defined. A stable and consistently performing VPN environment is highly cooperative, which means you really need to be working very closely with your customers to avoid a lot of these issues. Performance expectations, I talked about that before. They're difficult to enforce, obviously, because you're leveraging a network that's outside of your control in many cases. And blame games can be common between you and your customer, and obviously you don't want to be on the wrong side of that. Internal expectations. Ensure that your sales and marketing people understand what you're trying to do with the technology and what you're capable of doing. Obviously, we know the consequences of not having educated sales and marketing folks. And also educate yourself, know your customers. So I think running throughout the presentation, you'll see education is one of the main issues. When you're providing this type of service as a hoster, in our case, many of the customers aren't typically doing a lot of advanced networking at the smaller level. Obviously, you'll have large customers who this is really not an issue, but a large number of the smaller customers will. And also, setting expectations is essential. Letting your customers know what they can expect out of your VPN network is important. So some conclusions. Again, large majority of the issues around creating IPsec VPNs in this application are pretty mundane, and they're not usually technology related per se. In other words, you're not going to be looking at why, IKE phase 1's failing, etc. VPNs do not mitigate many of the traditional connectivity issues. They also combine many of the traditional WAN connectivity issues that you would see in the enterprise, etc., with the vagaries of the internet, and this quickly magnifies complexity. External issues affecting performance are common, and thus these expectations need to be communicated clearly. Issues over ownership of configuration, connectivity, and even hardware are common, so you need to, again, set the relationship, let people understand what your responsibility is, what their responsibility is. Know your target customers and ensure that your design is flexible enough to accommodate the vast majority without breeding expectations in your network. And education should serve as the foundation of your relationship with your customers. So that's it. Any questions? Thank you.